Hello guys, welcome to Self Help Maths Academy. Today we are going to discuss about the characteristic equation of the matrix. What do you mean by characteristic equation of the matrix? Okay, and how do we find it out? That will be the discussion of today. Now, let capital A be the matrix, say of order n cross n. It should be a square matrix, and then the scalar equation. Why I'm using the term scalar equation? Because it is determinant of a minus lambda I equal to 0, or we also write it as determinant of a minus lambda I equal to 0. So this is called as a characteristic equation of A. This is called as the characteristic equation of A. As you know that after solving the determinant you are getting a scalar. That's why we're calling this equation as a scalar equation. Okay. So here what is the lambda? Lambda is the eigenvalue of n cross n matrix A. Okay. If and only if it satisfies this particular equation, characteristic equation. That's why characteristic equation is very important in order to find out the eigenvalue. So let's see, take an example and we'll find out some characteristic equation for a given matrix. Say A equal to 2, 3, 3 minus 6. Let us find out the characteristic equation of this particular matrix. To start with, we know that it should be determinant of A minus lambda I equal to 0. So let's do that. So here we have A. The matrix A is what? Let us find out first A minus lambda I. So this will be equal to 2, 3, 3 minus 6 minus lambda into I is 1 0 0 1. It is a 2 cross 2 matrix. Okay. So now this is equal to, here we'll get 2, 3, 3 minus 6. If I multiply with lambda, I'll get here lambda 0 0 lambda. So this is equal to, the final matrix will be 2 minus lambda, 3 minus 0 is 3, 3, then minus 6 minus lambda. This is your A minus lambda I. But our characteristic equation is determinant of A minus lambda I. So therefore, this is our matrix. Let us take the determinant of this. So it is 2 minus lambda, 3, 3 minus 6 minus lambda equated to 0. Okay. So this is equal to, so it is simply 2 cross 2 matrix. So 2 minus lambda into minus 6 minus lambda, 3 into 3, that is minus 9 equal to 0. So solve this further. 2 times of negative 6 minus 12 minus 2 lambda minus 2 minus plus 6 lambda plus lambda square minus 9 equal to 0. So rewrite this. This is simply lambda square. Minus 2 plus 6 is 4 lambda minus 12 minus 9, which is minus 21 equal to 0. So this is our characteristic equation of the given matrix A. This is the characteristic equation of the given matrix A. If further they ask you to calculate your eigenvalues, then you will be solving it for lambda and then find the eigenvalue for the corresponding eigen equation, right? So like that. So for example, in this case, if they ask us to find out the eigenvalue, you will do the further calculations. So if they ask you up to characteristic equation, we will solve up to here. And if they ask us to find out the eigenvalues, we'll go further. After multiplication, I should get negative 21. After addition or subtraction, I should get 4. So the two factors will be 7 and 3. So lambda square plus 7 lambda minus 3 lambda minus 21 equal to 0. So here lambda I can take out, it is lambda plus 7, minus 3 I can take out, it is lambda plus 7, which is equal to 0. So lambda plus 7, then lambda minus 3, which is equal to 0. So here you will get lambda equal to negative 7, lambda equal to 3. So therefore these are your eigen values. Lambda equal to 3 and lambda is equal to negative 7. These are your eigen values. Okay. So like this, you have to, understand that how do we check? How do we check and how do we calculate the eigen values by using the characteristic equation. Okay, now let's see that if suppose they give you like this, we have the characteristic equation of a given matrix, and we need to find out the eigenvalues of with their multiplicity. So how do we actually check it? Let's see. If they given us, next example is the characteristic equation. Let me write it as CE, characteristic equation of a polynomial of a 6 cross 6 matrix is given by, say, lambda to the power 6 minus 4 into lambda to the power 5 minus 12 into lambda to the power 4. So we have to find out the eigenvalues and their multiplicities. So let us see. So the characteristic equation is given by lambda to the power 6 minus 4 to the power 4 lambda to the power 5 minus 12 into lambda to the power 4. Characteristic equation is equal to 0, right? So now here if you see, in each term we have lambda. Here I think I can take lambda to the power 4 as common from all the terms. So here I'll get lambda to the power 2 minus 4 into lambda, because I've taken lambda to the power 4, so I've left with 1 here. So here it is minus 12, it is equal to 0. Okay, so here if you see, this is lambda to the power 4 into this term is equal to 0. This implies either your lambda to the power 4 is 0, or you have to say lambda square minus 4 lambda minus 12 equal to 0. Okay, so this gives you what? Lambda value is 0 with how many times it is repeating? 4 times. So therefore it is with multiplicity 4, with multiplicity 4. So how many times it is repeating? That will be its multiplicity. Now again, by taking this equation, so here we have lambda square minus 4 lambda minus 12 equal to 0. So after doing the factorization, so lambda square minus 6 lambda plus 2 lambda minus 12 equal to 0. So lambda if I take out, it is lambda minus 6 here, plus 2 if I take out, it is lambda minus 6 here. So you will be getting here lambda minus 6 and lambda plus 2 equal to 0. This gives you lambda equal to 6 and lambda equal to negative 2. So clearly this lambda equal to 6 is having a multiplicity 1, and lambda equal to negative 2, it's with a multiplicity 1. Okay, so with multiplicity 1. So therefore what we have got lambda equal to 0 with a multiplicity 4, and lambda equal to 6 and lambda equal to negative 2 with multiplicity 1 as our eigenvalues. Okay, so let's have one important property which says, suppose, let's say it says, if n cross n matrices capital A and capital B are similar, then they have the same characteristic polynomial, and hence the same eigen values. If you say with the same multiplication. Okay, let's see what is the similarity. Is not actually as the same as the row equivalence. Row operations on a matrix usually change its eigenvalues. Okay, so similar, when I say similarity, it does not mean that after doing the row transformation, some matrices still looks similar. It's not that. So if n cross n matrices A and B are similar, then they have the same characteristic polynomial. When they have same characteristic polynomial, they have the same eigenvalues with the same multiplicative. Okay, so therefore you have to be noting this particular important theorem here. All right, now let's see another example where we will find out the characteristic equation, but let me take the 3 cross 3 matrix here. So if suppose I've given with, say, 1 0 negative 1, 2 3 negative 1, say 0 6 0, this is our matrix, say A equal to, and we have to find out the characteristic polynomial. This is also called as characteristic polynomial or characteristic equation, one another same. So what is our characteristic polynomial equation? Is determinant of a minus lambda I equal to 0, or you simply can write it as a minus lambda I equal to 0 with the determinant symbol. Okay, so now let us do this one. This is equal to, just subtracting the lambda value from the diagonal values, so you'll get this one. So here it is 2, 3 minus lambda minus 1, 0, 6, 0 minus lambda. This is equal to 0. Okay, so simply doing the determinant values. So here we get 1 minus lambda into 3 minus lambda into negative lambda, minus of minus plus 6. This 0 into anything will be 0, just leave it. So minus 1 into, here we get 12, and this is 0, which is equal to 0. Now simply 1 minus lambda, multiplying here, it will give you minus 3 lambda plus lambda square plus 6. So minus 12 equal to 0. Okay, so again still you multiply here, this will be giving you the value as minus 3 lambda, 1 with all the values, lambda square plus 6, with the minus lambda into inside multiplication will give you 3 lambda square minus lambda cube minus 6 lambda minus 12 equal to 0. So this will be minus lambda cube, lambda square, 3 lambda square is 4 lambda square, then this is minus 9 lambda, and minus 6 equal to 0. We can rewrite with the multiplying both the side with a negative sign. It is simply lambda cube minus 4 lambda square plus 9 lambda plus 6 equal to 0. So this is our required characteristic polynomial. Okay, this is the characteristic polynomial of the above matrix. Like this you have to find out the characteristic polynomial. Okay, let me give you one, and you have to answer me in the comment. Okay, comment box, what is the characteristic polynomial of this equation. So let me give you the matrix. Let A is equal to, say, 4 0 0 5 3 2 minus 2 0 2. Okay, what is the characteristic polynomial of this equation? Okay, and also let me give you one more. Let me give you B equal to, so B is minus 1 0 1 minus 3 4 1 0 0, say 2. Find out the characteristic equation or the polynomial of this particular matrix. Okay, answer in the comments, guys, what are the answers you're getting for this particular matrices. Okay, so this is all in this video. Maybe in the next video we'll discuss about the diagonalization. I think till then, take care, guys. See you all in the next video.